Hello everyone. In today's video, I'm going to be addressing the mid-segment problems with the, I believe it's 7.4 notes. Yes, perfect. 7.4 triangle mid-segment theorem. This has given students a lot of fits in the past, and I already kind of see some issues with it happening. So I figured I would thoroughly break down the example that's in the notes, just so hopefully you gain a little bit more clarity on this problem type. So we have an example here. Fill in the missing lengths of the triangle, and also you have to know that FG is your mid-segment. Something I forgot to add in the notes prior, so it's something I had you add in later. So FG is our mid-segment. With this, you have to understand that there are two components to a mid-segment. That's why I have this up here visible. First things first, your mid-segment is half the length of the segment that it is parallel to. So FG is parallel to CD. I hope you can all see that. And it's half that length. So if CD is 12, then FG is half of that. It's 6. So that's the first thing that the mid-segment does. So FG is half of CD. And half of 12 is 6. And then from here, we still need to find EF and GD. I'm going to use the second part of the definition. Your mid-segment will bisect any side that it touches. So in this picture up here, DE touches AC and AB, and as you can see, it bisects, or in other words, splits in half, both of these sides. Now the sides themselves can be different lengths, so that's why we have different symbols when we go to a new pair of halves. So FG, it intersects EC at F, so I'm going to have those markings there, and I'll use 2 here to be consistent with the picture above. And then it also touches at G, and it touches ED, so this is cut in half. So from here, we can say if this is 7, then this is 7. If this is 9, then this is 9. It's pretty straightforward. Then we can fill in the missing stuff. So it asks for EF. EF is here. EF is 9. And finally, it asks for GD. GD is 7. And that's it. There's really not a ton more we can find. We can find that EC is 18 if we add these together. And ED is 14, once again, if we add together. Nothing else we can do here as we only have one mid-segment in the triangle. So, reminder, you're working with basically 2 definitions, if you will. I just call them 2 parts of a definition for mid-segment. The first is that its length is half of the side it's parallel to, and that it also splits other sides in half. Any side that it touches, it cuts in half. So if you can remember those 2 things about a mid-segment, you'll be able to tackle any mid-segment problem. These are just about taking your time and looking for specific things. Once you've done enough of these, you know what you're looking for, they become a lot easier. If you have any additional questions over the mid-segment problem, either in the notes or in the homework for 7.4, let me know. Otherwise, you have a wonderful day. Bye!